So 2.3 is biconditionals and definitions. And I'm just going to tell you what a biconditional is, and then we'll do a few biconditionals and figure out how these work. But a biconditional is a single true statement that combines a conditional with a true converse with the phrase if and only if. Kind of sounds like your parents scolding you, right? I will get you that, whatever, if and only if you fill in the blank. You do not ever have to write those 4 words again for me. Every single time you may write IFF. Okay, if you put IFF, I know you mean if and only if. If you put IF, you will get it wrong. So if you're trying to use if and only if, you may abbreviate it, just make sure you abbreviate it correctly, okay? It has to be IFF, if and only if. So here's how this works, okay? If you can write a conditional statement and it is true, and then you can write the converse. What does the converse do? Switches them. And that also is true. If you can do it both ways, they are both true, then rather than have to write 2 separate statements, you can write it as what's called a biconditional and just take out the if, take out the then, and put in an if and only if where the then used to be, okay? So let me show you what I mean by that. On this first one here, it says, if the sum of the measures of 2 angles is 180, then the 2 angles are supplementary. Is that true? That's true. Okay, so we know the conditional is true. Let's check the converse. What would the converse say?
If the 2 angles are supplementary, then the sum of the measures of 2 angles is 180.
Right. If 2 angles are supplementary, then, God bless you, the sum of the angles is 180. Okay, is that true? That is true also. Okay, so here's the deal. If conditional and converse are both true, then you can write it as a biconditional, meaning this statement will be true both ways, and we don't actually have to write it both ways. So the biconditional does this, and I'm going to do this, just show you in green up here. You're going to take out the if, you're going to take out the then, and you're going to put the if and only if in place of the then. So we would say 2 angles are supplementary if and only if their sum is 180, okay? Now, because it's true both ways, I don't care if you write that biconditional from the original or if you write it from the converse. I did the converse just because it was a little more spaced out and easy to show you, but you could do it right here as well. Take out this if, take out this then, put in the if and only if, and you could say the sum of the measures of 2 angles is 180 if and only if the 2 angles are supplementary, okay? So the biconditional can come from either the original or the converse, okay? Questions on that? Okay, so in terms of if P then Q, this is what it's saying. We know that if P then Q is true. We know that if Q then P is true, right? That's the converse. Therefore, we make it P if and only if Q. Notice the difference in the if P then Q arrows, right? The arrows are going both ways now. So it's saying you could write it either direction. So P if and only if Q, okay? All right, so the reverse of that is also true. If you have a biconditional, if you have an if and only if statement, you can turn that into a conditional and a converse that are both true. So it's kind of the reverse of what we just did on the first problem. This one says a ray is an angle bisector if and only if it divides an angle into 2 congruent angles. How do you make that a conditional statement? Yeah, Krista. if array is an angle bisector, okay, so she added an if at the beginning, took out the if and only if, put a then in the middle. So then it divides an angle into two congruent angles. Okay? So what would the converse of that be? And just be careful with converses. You want to make sure that you know at the beginning of the sentence what you're talking about. So even though right here it says it divides, we want to know what it is right off the bat. So don't say if it divides. You want to say if what? What is it? If array, right? We were talking about array initially. So if array divides an angle into two congruent angles, then it's an angle bisector. Okay? Questions on that? Okay, so sometimes you'll be given the biconditional, you have to get the converse and the conditional. Sometimes you'll be given the conditional and its converse, and you'll have to make the biconditional. Okay? Okay, good definitions. I know, again, feels a little bit like English class, right? We're talking about definitions. But when you're dealing with the types of conditional statements that we are, you have to know if something is true or not, right? And then therefore know if it is a good definition or not. So you're going to be using a lot of math terms with good definitions, but still definitions, okay? So there's three things that we're going to talk about that make something a good definition, because I'm going to ask you, is this a good definition? You're going to check, are these three things true? If it is, then yes, it's a good definition, okay? So number one, something is a good definition if it uses clearly understood terms. Okay? So if I was talking to you about a, man, that dingle hopper really worked well for me yesterday. Does anyone know what I'm talking about?
Yeah.
What?
A fork.
Good job. It's a fork. Do you know what that's from? Don't tell them. The Little Mermaid, right? But if you haven't seen The Little Mermaid, good luck. You don't know dingle hoppers, okay? Snorfplat. Anyone know what a snorfplat is? It's a pipe. Yep. But again, if you don't know The Little Mermaid, you don't know that. So not a good definition for me to say or talk about a dingle hopper obscurely, right? So it needs to be clearly understood. A fork. Everybody knows what a fork is. Dingle hopper, maybe not so much. Second thing is it needs to be precise, okay? You need a precise, accurate definition. You don't want to use sort of. Nope, that's my next one, 2 blanks. You don't want to use large, okay? Because what is large to me and what is large to an ant are very different things, right? My daughter Kenzie is large to an ant, and she's very small to me. So don't use large or sort of. What's the other one? Almost. Okay, we want as exact and detailed, precise as we can get. Okay. And then the last one, if it's reversible. So if, like we did at the beginning of the lesson, if you can write a biconditional from it, it's a good definition, okay? And that's the one that I feel like is usually the easiest to check. Like, can I write it both ways and it's still true both ways, okay? So let me give you a definition. Sorry for the gap. It's just the change of page. Is this definition reversible? If so, we're going to write a biconditional. Okay, so the definition is this. A quadrilateral is a polygon with 4 sides. Okay? So think about the conditional and its converse. How could you make that a conditional statement? Yeah, Jason.
If a polygon is a quadrilateral, then it has 4 sides.
Right. Okay, so if a polygon is a quadrilateral, then it has 4 sides. Is that true? Okay, so the converse then would be if a polygon has 4 sides, then it is a quadrilateral. Is that true? Also true. Okay, so if both ways are true, then you're going to take that statement, that definition, and turn it into a biconditional. This one didn't have if-then to start, right? So you don't have to take out an if, you don't have to take out a then, you just have to put in what? IFF, if and only if, okay? Where's that going to go? Right there, right? A quadrilateral or a polygon is a quadrilateral, because we got to switch that around, right? Polygon is the like overarching figure. More detailed is a quadrilateral. So we would say a polygon is a quadrilateral if and only if it has 4 sides. Okay. All right, so 4 definitions. Tell me if they're good or not. If they're not, tell me why not. Okay? Number 1, a fish is an animal that swims. Good definition? Can you reverse it? If an animal is a fish, then it swims. If an animal swims, then it is a fish. Nope. I had a dog that swam. I don't have him anymore, but I did. So this would be no. It's not reversible. It's not very, well, yeah, it's not reversible, right? We'll just say that. Okay. Number 2, rectangles have 4 corners. Is that a good definition? If a figure is a rectangle, then it has 4 corners. That's true. If a figure has 4 corners, then it's a rectangle. Not true, right? I could say this has 4 corners, and that is not a rectangle. Or 4 corners, like what's a corner? It's just not very well defined, not very precise, we'll say. So we would say no, that is not precise or detailed enough. Number 3, giraffes are animals with very long necks. Good definition? What word would you say is the issue here? Very long, right? That's not precise. There's lots of animals that maybe I think have very long necks. I think an ostrich has a very long neck, right? So not precise and not reversible. Either one of those would be fine. Number 4, a penny is a coin worth 1 cent. Good definition? That's a good one. You can reverse it, right? If a coin is a penny, then it is worth 1 cent. If a coin is worth 1 cent, then it is a penny, okay? Now, some may argue, what if you go to a different country and our penny is the same as their whatever, but it's only going to be the same as their other, whatever their unit is for a little while. It's not a constant, because money is always changing value in terms of inflation and whose dollar is worth more right now. So this we would say is a good definition. Okay, any questions on that?